This is the book club for my in-progress book, Web APIs with R, brought to you by the data science learning community. And today we are going to be talking about primarily about authorizing API requests. Before that, I just wanted to say I'm trying to break the book up into like digestible pieces. And so I've gone through the table of contents and made more sections. So instead of just one section that's all about accessing APIs and then, or whatever unit or part or whatever I want to call that, top level things, instead of one that's about accessing and one that's about creating, the accessing one I split up into like getting started, getting more data, finding APIs, and then doing more, which is kind of the catch-all, everything left over. Not a big deal on that yet, but just want to let everyone know. And then within this chapter, sorry, kind of fly buzzing around me. We went over it last week, but I'm going to go through the beginning of what we already saw relatively quickly, and then slow down once we get to what we haven't seen. But please feel free to slow me down at any point if there's something you want to ask a question about or go into in more depth. All right, so just to reiterate, I have not changed these, that the learning objectives for this chapter are to be able to provide information in your request about how you're accessing the API. And actually, I lied. I did change that to clarify what user agents are for. So we'll talk about that a little bit. We're going to talk a little bit about finding authentication information in API docs. And then we should be able to authenticate a request with an API key, and we should be able to authenticate a request with OAuth. All right. So just right off the bat, kind of reviewing the user agent discussion, I wanted to focus in on the point of a user agent is, or the point of a user agent header is to tell an API like how you are accessing that API. And so I reworded things a little bit. Instead of this being about telling the API who you are in this part, we're really telling the API how you're accessing it. Now, in some cases, actually that's on the next slide. So this is pretty much all the same, just a little bit of wording change at the top. I still show the default user agent from header2. But I did change a little bit in should I override the default user agent? Most of the time, just using what's there as the default is fine. We talked a little bit about this last week and how to decide, and I expanded this a little bit. So I had mentioned before that if you're hitting the API just a lot, it's probably good to let them know kind of what you're doing in your code. So if something is really taxing their servers, they can contact you, that kind of thing. Likewise, if you are providing code to other people, like if you are making a package that people will use to hit the API, by default, telling the API that those people are using your package is a good idea, because that way, if you're doing something consistently wrong, they can tell you. And then the other one that we talked about a little bit last week is the one API we were using as an example asks you to put certain things in the user agent so that they can contact you, and they'll automatically put you into a pool of faster access. So in that case, definitely do it. Like I mentioned last week, I don't think that it hurts, but I also don't think it's something to do all the time just to kind of gum things up. Because mostly they would want to know, hey, people using header2 are consistently failing on our server. Maybe we're doing something weird, something like that. So in order to override this, we talked about this, that there's the header2 rec user agent function that you can just put any string in there and it'll override it. The convention is to put like the software and then a slash and the version number, and you'll often have a bunch of these. So whatever your like browsers, if you look at the kind of default user agent on a browser, it will say the browser and the version, but it also say like the style of browser that it is. It's based on Chromium and what version that's based on, and it might say other pieces of software that are used within that. And then the other part of the convention is have parentheses with more details. That's where you would put like contact information, that sort of thing, separated with semicolons. I showed this last week that I have this thing that I've been playing around with, but I think actually before the next time this chapter is used in a club or anything, I have my Nectar package that is meant for wrapping. It's like a helper package for Hitter2, and I'm going to put a version of this code into that package. The idea is make something that's a little bit like a function that takes arguments from you to build the user agent rather than you just supplying the string straight up. So we'll see a new version of that the next time we look at this code. It'll be kind of inspired by this, at least. Yeah. So yeah, definitely I want to show what it looks like on Firefox versus Chrome, that sort of thing. Like these are the things that most things are, most of the time you access a web server, which APIs are using the same thing. Mostly it would be through a browser. And so, yeah, we'll show that. There is this default is kind of an example. That's Hitter2 1.01, and then the R curl package 521, and the libcurl library 830. So that's kind of a standard to see what they look like. All right. Oh, and Jim asked about Nectar, and I have a family of packages. I think Nectar is going to make it into the book the next time I go through everything. That is more my like closer to user-facing package. It's actually mostly meant for package developers, but I'm realizing more and more that all these helpers that I've shown, they kind of belong in Nectar. So that one will be making it into the book. Yes. All right. Finding authentication information. I didn't really add anything here. But I did when we talked about the types. So, we had a big discussion in Slack, and I think this made this a lot better. So kind of the 4 key types of authentication that we talk about, the basic level HTTP basic authorization. What is the no about, Jim? Okay. Yeah. Well,
can you hear me?
Yeah.
In the draft version of OAuth 2.1, it drops a lot of these authentication methods that are now frowned upon.
That's great, but most APIs, not most, actually, yeah, I'd say probably most APIs don't use OAuth, even version 2. And so they certainly don't use 2.1. And so since this is about how to access existing APIs, and I guess maybe I wasn't clear about that, but you as a user don't get to choose what type of authentication to use. It is whatever is set up by the API. And so if the type of authentication that they're expecting is HTTP basic, that's what you have to do. And I do want to tell you that if that's what they require, you should really think about whether you want to use that API, because with basic, you are sending your username and password with every request. And the analogy I would make is that that's like using the deed to your house to authenticate that you belong in your house, and like taking that and using that as your key. It's dangerous. You don't want to do that. Next level up is API keys. I'd say it's hard to say for sure, but a lot of APIs use just an API, a simple API key. This is just a something like a password, a string of numbers and letters that you have to send with your request saying this is me. I think of this more like a key. Like if you give someone the key to your house and then you decide you don't want them to have a key to your house, you can change the lock. It's a pain, but it's not the end of the world. They don't have the deed to your house. Not that just having the physical thing to do it, but so they have this key, and anyone who has that key can get in, which is something that kind of I have a problem with. That the next level up is called a bearer token, and they stress that it's called bearer token because whoever bears it can use it to do whatever it's able to do. But that's true of an API key. That's true of username and password. That if they have the thing, they can do the thing. But it is so a bearer token is kind of like an API key. It's it's meant to be a short-lived, limited API key. But another thing to stress here is that while that's the terminology, there's nothing that enforces this difference between a bearer key and an API key. Mechanically, the difference between a bearer key and an API, or a bearer token and an API key, is you pass a bearer token in a header that has the word bearer at the beginning of it. And really, that's the only difference. They should, the API provider should implement bearer tokens in such a way that they're short-lived, that they have limited capabilities, that you can revoke them easily, but they won't necessarily do that. Just to really reiterate that. On the other end, when we're creating APIs, we'll talk a lot more about how to properly implement them. But so the idea of a bearer token, it's more like a key card. It is something where you can give someone a key card and they can access a single room, and then you can just flip a switch in a database, and that key card no longer does anything. The key card could also be set up to access 2 or 3 different rooms within an office building, for example, but it wouldn't necessarily be able to access everything. And importantly, the end result of OAuth, which is the main thing that we're going to be talking about, is a bearer token. And again, it should be a proper short-lived bearer token. A lot of APIs, they go through OAuth, and then they give you effectively an API key that lasts forever after you set it up. So they don't have to implement it correctly, but if implemented correctly, a bearer token is a much more safe way of doing things because it's much smaller scope.
John, I have a question about this, which I know it's review from last time and I should know this, but are there times when, so you just clarified that bearer tokens, that is the name that you're passing it to the bearer as a bearer, but are there times in which you're using bearer tokens and yet you think as a user, it seems like it's an API key? I mean, I'm just asking, like in GitHub, the API key expire, but as a user, I think of them as just being an API key, but is that just a bearer where you have an option for it to not to expire?
I can't remember, but I am pretty sure that GitHub access tokens are actually bearer tokens. But the word API key is used interchangeably there.
Okay. And so that's common on the most high level user facing thing, even though under the hood it's going to say bearer somewhere.
Right.
Okay.
There isn't a hard line between API keys and bearer tokens. There's a conceptual line of how they're meant to be used.
Okay.
But if you think about it, if you have set up a access token for GitHub, it has a page where you choose all the capabilities that it has, and you set how long it's going to last before it expires. And you can go into your account and turn it off. And you can have several of them. This one is for this purpose. This other one's for this other purpose. That makes them more like a bearer token. So,
why did you use that language of more like rather than just saying are?
Well, because I can't. So technically, the difference between a bearer token and an API key is you pass it in a header or a query or through a cookie, which is also in the header, with just like name and value. Versus a bearer token is the authorization header colon, authorization, bearer, and then the token.
Okay, all right.
So technically,
You
it's
can't
a
tell
like
unless you're looking at that.
specific type.
Okay.
And the way like it's a function in header to use a bearer token, you'll almost never have to use that function because you're probably not using the bearer token directly. You're using it through whatever issues it. But yeah, that's the example. And okay, is this? Oh, this is it with header. Looks like. So, off the top of my head, I don't know. I think authenticate. Oh yeah, that looks like it's HTTP basic authentication because it's using username and password. Yeah, Jim.
I don't need to quibble, and you know much more than I do, but the little I have read, it's access token, and I know it's confusing because for a long time I was confused. Okay, all right, okay, I gotta go.
Technically, okay. So on your question, Gabby, that is, I mean, it's a type, but it's that's using header, and I don't know. Access token is a type of bearer token, technically speaking, but read 3 guides to OAuth and you'll see it called 3 things. We're going to talk about that a little bit in the next section. Okay. And just, you have your hand up, Jim. So if you try to raise your hand again, I won't know. Okay, there it went down. So, all right, OAuth is seen, and it's like it's sold as a type of authentication, a type of, on the same level as, oh, don't use an API key, use OAuth. But really, OAuth is a process. And at the end of the process, you get a bearer token that is called an access token or an OAuth token or lots of different things. But it's like that. It's a background check to issue the key card. It is the permission system that decides where, whether to issue it. And just to answer that question, Rebecca, that code is header, not header 2. And the way you can spot it is header has the uppercase post and get and put and whatever the other method functions are. And so if you see those all caps post or all caps get, that is a header, header 1 call. There are some other things that we mentioned before that I'm not really diving into. You can use SSL certificates as part of the authentication. I actually have in my notes that we're not going to talk about API keys and cookies, but we actually are a little bit because they're not as different as I was kind of thinking of them. So we'll get there in a sec. All right. Next couple of slides I'm going to blow through because I haven't changed anything about how to find them, and it remains that it's not that easy to do. Yeah, if you have the API description, you should use that. All right. I did add a little bit. I think we had talked about practicing safe get. I think this is mostly the same. I made some notes to myself about what this does exactly. So it's going to add rproj.user.rhistory.rdata.header.oauth.dsstore and .quarto to your global git ignore, which means those will be ignored in your or by get. You won't accidentally check them in. The important one in that list, why this is considered like a standard, is this header OAuth, which is header 1's way of storing OAuth information. It would put it in this folder or in the file can't remember if it's a folder or a file, but whatever, in the project directory, wapir02 intentionally puts it into a standardized cache directory that is not within the project so that it's harder to accidentally check it in. So they took care of that piece. It's still useful to do this, but it's, and you know, our history is good to not check into your repos, but this is less of a thing if you're using wapir02. A lot of times though, you might, especially if you don't do what I'm going to talk about on the next tab, you might have a project R environment where you're setting up API keys and that sort of thing. You just want to make sure that you don't check that into your Git repository. Yeah, sorry, and I didn't update my notes. That I also made a separate slide about this is a thing that it's one of those things that I thought was going to be a big effort to learn how to use, and then I went and used it, and it's like, oh, this is easier than using environment variables. So this is what I would definitely recommend now, is this package keyring. It's on CRAN, it's fairly stable, and what it does is ties into the various like Windows and Mac OS and the various Linux flavors have their own like password manager, more aimed at like API key managers built in. And keyring is built to like figure out which one, you know, which type of system you're on and tie into that. And so with keyring, you can use like keyring key set and the name of a service. So for example, keyring key set FEC API key. And then it'll give you a password prompt where you can type in that key. It's better than typing that into your R history or even putting it into an environment variable, a .r environment file, because it is never saved anywhere in plain text if you do it this way. I mean, other than maybe where you got it from. So it's useful. Another one that we actually didn't get into, I thought we would show this in the slides, but I didn't get there. Probably going to be more important. Like, I don't know if it'll ever make it into the book, but there's keyring key set with value where you can give it the actual password value. That's what this password equals null. You can fill in a value, and where that's useful, I didn't show the transition. I'll probably include this function somewhere in the book too, that if you're transitioning from stuff that's in your R environment to keyring, you can just pass your environment variables through this basically, and automatically set things. Yeah, I was having a discussion. So Mael from our OpenSci and various other places, and then Gabor, who wrote it, they're active on a Slack that I'm on, and I was like, why is this not the standard? Like, why is it not standard good practice? And they were both like, I don't know. So they both do a lot with APIs and agreed that it would be good to kind of start pushing it to be standard practice. So here we are. And then the other side of it is key get. And so like key get FEC API. Oh, and okay, I do show this, that you might need to copy keyring to your environment variables for packages, because a lot of older packages just look for an environment variable for your API key. It's like there isn't even a way to type it in. So for example, you could do sysset and FEC API key equals keyring key get FEC API key. I have some functionality currently in my profile, to my R profile, to do this when I start R. So instead of storing things in .r environment, I store them in keyring, but use them as if they're in .r environment. This is a whole separate thing. I'll have a blog post or something about this at some point, and to some degree at least, it's going to make it in the book, but I wanted to bring it up because it is definitely useful if you're working with APIs. Use keyring. You can use this function in kind of as the reverse of this. that do a sysget as your password to pass things into keyring, and then do that once, and then every time you load, you can do this transfer back to environment variables. All right, so then we get into the actual meat of how to do things. I want to go a little bit through. Oh, yeah, I did totally change this one again too. So for API keys, we've seen some API keys, some FEC API key, for example, where it just gives you a key. Maybe it's demo key, or maybe it's some other specific thing. There are 3 ways that API keys can be sent, actual API keys. Yeah, so just to pause a little bit, that everyone uses .r environ and puts your API keys in plain text in that .r environ. It's not, and that's not just an R thing. It's a pretty standard way of doing things on a lot of systems. And you shouldn't. Like, I mean, a lot of times API keys aren't that secure. You can deal with it if they get leaked a lot of times, and so people don't treat them as they should to a large degree. But yeah, so keyring kind of takes it off the next level. All right. We had seen back in OpenFEC, if I go to the security schemes, there are these 3 schemes for their API keys. They almost do the service of showing us all 3. They actually have 2 that are the same thing, and then 1 that's in the header. But they tell you can set it in the header, and this is the name that it should have. It's an API key security scheme, or send it in the query, and it will be named API key. In both cases, this is a type of security scheme called an API key security scheme. So it can be in query, and if in that case, header2 rec URL query lets you pass it in the query. One of the other places it can be is in the header. There's the function header2 rec headers, where you can just pass in name value pairs in the dots here, and then the .redact will hide it in the print. We talked about this last week. So that's a character vector of headers that you don't want to show up when you print things. I'm going to show an example of that in a second. The thing I did want to add that I hadn't really, wrapped my head around how to explain before is that the third place they can be is in the cookie. So yeah, so there are 3 places. No, so cookie is actually a header. We think of it as a separate place. You can store it locally as a file. You send it as part of the header of an HTTP request. And so I'll come back to your comment in a moment, Jim, but that made me realize that you shouldn't think of cookies as anything different. They're header2 rec headers, and then you just say cookie is the name of the header, and it gets name value pairs separated by semicolons. So name equals value, semicolon. And so you could just put your, if there is an API cookie, if you happen to be working with some service that only accepts the API key as a cookie, then you can put it in the cookie. And then I do say .redact because you don't want your API key printing. There's a lot of stuff happening, or like a lot of hatred for cookies. Cross-site cookies are the thing that's awful, but everyone catches up. If it's a cookie for the site you're using and it's just holding your login information, that is useful. It's a way to store information on your local machine in a semi-secure way. And so that's all that is in the browser, it has a meaning. Outside of the browser, we don't care. It's just another type of header. All right. So for the OpenFEC, we looked at that example that it has these 3 types, but of the 3 types, header is better. Header is at least slightly more secure because it's not just being sent in the URL. It's pretty easy for things to access. what URL are you going to, and if the API keys in the query, that's part of that. And so it's easy for things to see that you're doing that. If you put in the header, it's a little bit more hidden. And so if we use rec headers, we say XAPI key equals demo key, tell it to redact that. When we print it, it's redacted. It doesn't show up in the print. Again, it is in the object, so like you can find it, but you know what your key is anyway. But it doesn't just print into a log that things can easily see. And then you can see how like something like keyring keyget can be useful here, because it's going into this header for this command, and again it prints as redacted. So it's never like, you don't even necessarily have to know what your key is at this point. It's not in your code. It's just a reference to your key that's in the code once you have set this up. I'm going to show it also with get env in a second as the opposite or optional way to do that. So Jim has a question, and actually you have two, so I'm going to go back to the other one in a second. But surely there must be an easy way to encrypt or decrypt so that you're never sending info in the clear. But I mean, kind of. Somewhere it has to be in the clear, or it doesn't. Like, how did it get to where it was encrypted? So at some point it is stored unencrypted. Like, yes, this thing that I just showed, technically the password or the key is unencrypted in your memory, but like, if you're always sending it encrypted, then that's the same, that becomes the unencrypted thing. Like if it's always encrypted, then it has no meaning. You know, that's the thing that could be transferred and captured. And so you have to have both encryption and decryption happening. So it's like I kept wanting this to be true, but at some point you have to decrypt to use the thing. And then you can re-encrypt it to store it and that sort of thing. So not really. I mean, so you're sending, if you're using HTTPS, all the other info is secure. That's what the S is for. But if you're sending the encrypted thing and had to enter the, like, either enter the encrypted thing or enter the unencrypted thing on your computer, at some point it's being sent as that thing. And if people are capturing the encrypted thing, by the way, so what? They're still able to access your account. They didn't need to know what the actual password was if they can just send the encrypted thing. So the trick is to not send it in the clear. Like if it's in a header, that is fairly invisible. Like it's not easy to get a hold of that. If it's in the URL, that's bad, and that's why you should, query sending, like the least secure would be sending username plus password in the query. But the step just below that is sending the API key in a query. Now, for something like FEC API, where in order to get an API key, you have to fill out a form and it'll instantly give you an API key, it's not that big of a deal if someone steals yours, because so what? You get another one. Or so what? They also use yours. But for, obviously, if it's something that, your bank or something like that, it's a bigger deal. And you have to be careful about that. And so you mentioned, there are three ways that get transfers info: query, header, and body. Was question mark. So for the most part, get, which we've only talked about get requests so far in the book. Get usually doesn't have a body. It technically can have a body, but usually it's just a query. Query being the URL that you're sending it to, and a header being information about what you want. We'll talk in a couple of chapters about posts and other types of requests that tend to use bodies, and mostly So, or actually by default, hit2, if you have something in the body and don't tell it not to, hit2 is going to assume you're making a post request, because that usually is what that means. No, it's not 100%. And we'll talk about that a lot more in a few chapters. All right. So again, this is like the first place where I've specifically talked about Nectar, but Nectar is this package that I'm working on that mostly what it does is translates the open API specification, so API definitions, into Hitter. So with Nectar, I have this function recauth API key. You give it a location, the parameter name, and the API key, like the actual value, and it translates to that code that, translates to this code, basically. It's just made to be a little bit more transparent. If you're going from the API doc, you can use it kind of more directly using the same thing. Nectar has been aimed primarily at package authors, but I kind of had this epiphany of, oh, right, anyone using APIs, it's kind of just, it's my list of helper functions to more easily translate from the API documents, API definitions over to Hitter2. And so probably going to start making it a little bit more user facing. Okay. I'm sorry, I'm getting like a ton of notifications about various messages, and I keep having to check to make sure it's nothing important, and it's so far it isn't. So okay, now let's see how much of the new content, the really new content we can get through in the last 20 minutes. So like ideally, most of the time you will be using OAuth, and I'm going to go into it in the book. I don't really show it on the slides here. Technically, when we talk about OAuth, we're talking about OAuth 2. And soon we'll be talking about 2.1, which, as far as I can tell, is mostly just clarification of meanings. But technically, there was an OAuth 1.0. Hitter has some functionality for working in OAuth 1.0, but you almost never see it anymore. People either use OAuth 2 or they use something like just an API key. All right, so how can we authenticate a request using OAuth? Yeah, and so OAuth 2 was in 2012. Surprised it wasn't before that, actually. 2.1, I'm not sure how new 2.1 is, because OAuth 2 kind of includes 2.1. 2.1 has some more specification on it, but it's right, it's in draft. You're not, again, not really important for this side of things, because until people implement it, then you can't use it to access API key or APIs. All right, so first some terminology, which will still also apply for OAuth 2. And I am not happy with this in slide form yet. Like there's a lot of information and I haven't gotten down to kind of the order to present things, but we're going to go through things kind of a few times in like all this stuff interrelates with one another, and hopefully it'll make some sense, and we can improve this over time. So I'm going to try to go through some terminology, and then we're going to talk about how all this stuff gets used, what the whole point is. But I just want to stress, I had mentioned this before, that it is complicated. So don't feel bad if you're confused. I have read many articles about like, why is OAuth still confusing? Like that'd be the title of the article from a company that makes APIs. So it is confusing. And the more I've used it, I feel like it's because it is complicated. Like you can only get so simple with something that actually is complicated, and it's complicated on purpose to help with the security check process. So that is what it is. You'll see things refer to it as the OAuth dance a lot, and I have a slide about the OAuth dance in a couple of slides. The reason there are multiple steps, that this back and forth thing, is to make it harder for an attacker to intercept, to minimize what they can do if they do intercept a step. And also because technically OAuth is to allow a third party to act on your behalf. And so that's what we kind of talk about on this slide. It can be confusing because when you're writing code to interact with an API, you are probably both the user, the person who you're acting as, and the application or the app, which in our case is your R code. And yes, I know that this should be a picture. I haven't gotten there yet, and I'm not an artist, so we'll get there. Anyway, sorry. So in our case, our code is the app and we are the user. So it feels like, oh, that's the same thing. And so a lot of the documentation is like, what? I don't understand what this is talking about. You have to remember that you are two people in this whole dance. You're writing, especially if you are writing a package, you're not using someone else's package. You're the app and you're the user. Because OAuth is designed primarily for websites, like, log in with Google is using OAuth. If you log into some third-party website, or if you are, authorizing something to use an API for you, like you link LinkedIn to your profile on some site, that is using OAuth to authorize things. And you're telling you're telling LinkedIn that it's okay for whatever website you're on to act as you. That's the three participants of OAuth. So user, app. There is a kind of middle term, client, which is the thing that as an app creator, you set up at the API to tell the API what your app is. So this is kind of an extra participant. This one really is your app. They're kind of one and the same, but it's the registration of your app with the API. This step is always confusing. It's worded a lot of ways. Sometimes it's called your OAuth application. I think even in Hitter 2 they call it a couple of different things. But it is just like the reference to your code, your app, your setup at the API. And that is something that can be really confusing when you're trying to set up OAuth for your own code, that you're like, but I already have a user. It's like, yeah, but you need a thing that is used, like if they only allow OAuth for authentication, like YouTube does, a lot of the Google things only allow OAuth. You'll need to do that. Now, I guess to back up for a minute, a lot of times things will have both like API key and OAuth. If you are just like trying to read data, you can just use an API key, no big deal. But if you're trying to act as yourself, like go in and make changes, upload YouTube videos or things like that, then you need to use OAuth. And so that's where things can be extra confusing. There have been many where I'm like, well, I've got this API key, and then I also have a client ID, and I have some other things we're going to talk about in a minute. It's like, yeah, those are two separate things. So, all right. So the client is your app as it is registered with the OAuth host, and then the host is the API or Google or LinkedIn or whoever. It is the place that you are authenticating with through OAuth. The bold on these is what I use on other slides to refer to things. Let's see, the app could be a package. It could be, just your script. It could be a website. It is the thing that is registered with the host. And we'll talk about like what comes with the client in a minute. So you set up the client, you give it some information. I guess I'll talk about this here a little bit. That it has an ID and a secret. We'll talk about when you use those and what those are, which actually should be on the next slide and isn't. Okay. And then also on that page where you're setting up your client, you do things like they'll require you to have a link to a code of conduct or maybe a link to a license. It will allow you to customize what shows to the user when the host is asking the user, can this app use or be you? And a lot of times that'll feel weird because you're like, I just want this for me. I don't care what it says to the user. I am the user. But that is how you can tell, is this my code that is, or my client that's doing this, or is it someone else? And then importantly, we'll talk about in a minute, you also set up there, like, where will the host send verification information? Where can the host talk to your app? And we'll talk about what that means in a minute. All right, and the next step, or next set of terms that I'll be using as I describe this to you. Scopes. So a scope is a string describing a specific capability. So we've talked a lot about how I'll answer that in a second. We talk a lot about how bearer tokens are supposed to have limited capabilities. The way you limit those are called scopes. And so if you read any of the Google API documentation, they will say, this thing requires, read user scope, and it also requires read playlist scope, and it requires, all these different things. And they actually give the scopes as URLs, but it's just a string describing what is this key able to do? What is this bearer token able to do? Next step, which will make more sense when we see the step-by-step version, but there's authorization code. This is a very temporary key. Actually, we'll talk about that more. You don't really need to know anything about that here. And then finally, the OAuth token, or the token, part of which is the access token or the access key. That is the thing, the final real key, the thing that you're using to access their site. This OAuth token often includes things like when it was issued, when it expires, a special token that you can use. It's called a refresh token. We'll talk about that in a minute. It includes other things in addition to the access key, which is part of why it's called, it has its own special name. Some sites, the OAuth token will only be a single string, and it is the access key. It is the bearer token. They're all one and the same thing. But that's part of why you'll see kind of really confusing terminology, is that they all kind of overlap. Like the OAuth token contains the access key, which is a type of bearer token. So all of that can be confusing. Do the people running the API have a log of all the things I downloaded using my API key token, etc.? Maybe. That is purely depends how they have set it up. Probably. They probably logged what you have done with that key, although it might be a non-permanent log. Often that is why, like on the FEC API, you can just use demo key, or if you use the one that they issue you, you can do more, but also they can turn it off. And so that is so they can, it's, hey, this one is hitting us a lot. Let's shut that down because it's going to kill our server, that sort of thing. All right, and then the final bit of just terminology. There are three URLs, or three types of URLs that we'll talk about. There's an authorization URL. This is going to come up in some of the functions, or the auth URL. That's where do we send, or where do we talk to the host? Where do we send information saying, hey, we want to authorize this? Redirect URL, one or more redirect URLs, are a thing you set up for your client, which is where the host is allowed to send people back to with the code, the authorization code. And then token URL is the final place where you exchange this authorization code they give you. Your app exchanges that for a real, for the OAuth token. And all of this should make more sense with the next slide. I just want to read my notes and see if there's anything. Just importantly, the auth code can only be sent to these redirect URLs. It has to be something in this list. So if you make a request and say, okay, I'm sending this user to you to say you're okay, and then if so, send the code back to this URL. If you give them a URL that's not on that list, they won't do it. That will stop. They'll only send things to the URLs that you have set up in your client. That is a piece of the security. And in Hitter 2, Hitter 2 will set up a server on your machine that the codes can come back to. And so there's information in the Hitter 2 documentation, which I will show in in the book, of how to set, or what to say in the client, basically. Usually it's localhost, but sometimes you have to say that in a different way for it to work. The other piece about this is this token URL. This last request, part of the reason that there is this last request is this is sent like directly server to server. There's no user in between, no browser. And that's when you get the real code, because that's the most secure piece. It's like way harder to intercept that. It's going like out as a different type of request, that it's all within the body in the header, and it's hidden. So we'll talk more about that, a lot more about that much later in the book, because mostly we just let Hitter Hitter 2 rather, kind of deal with that. All right. So now the actual dance. And as I mentioned, this has a big to-do to me written here to make some sort of image version of this. But for now, I'm doing it as kind of a conversation. So I mentioned before, this is sometimes called three-legged auth. And it took me forever to figure out, why the heck do you call it three-legged auth? What's the three legs? And it's, oh, there's the app, the user, and the host. And usually I am two of those. So that can be really confusing. So, all right. First thing that happens is, a user, being you, will come in and say, hey, hit this API for me. So it's saying, the user's telling you, I want to do something. Now, this could be, again, just in your script, could be a Shiny app that you're making. It could be, someone else using a package that you write. So there, the user comes in, says, hey, hit this API. The app sends the user through a browser to the host at that authentication or authorization URL, the auth URL. With that, we send a client ID and a list of scopes. And so the host can ask the user, hey, can this client, this thing that all I know it is this client ID, can it act as you with these particular scopes? Can it read your email address, or can it write messages on Slack as you, or whatever you're asking the API to do? If the user says yes, so the user gets this page and has information about how it will be used. That's, you've probably seen those if you've logged in with Google. Google will say, hey, we want to log in, or this thing is requesting access to your account. You want to let it do that. A lot of times you probably don't read very closely, but probably should. You say yes. And so if you do that, the host is going to send a thing. So it also is sending the user to a new URL. It's got to be one of the redirect URLs that was specified for that client. And that new send has the auth code in it. And so that auth code, technically the user is loading it, but they're loading a page on, that is your app, that represents your app in some way. Which is, so that has that short-lived auth code. And then at that point, the app talks directly to the host at that token URL, says, okay, I've got my client ID, here's my client secret. This is the only time that I'm going to send this client secret. And I've got the user's auth code. So put those together and let me act as that user. And then the host will send that, send back to you, or will reply to that request with an OAuth token, which has the access key in it, the access token, the access bearer token inside of it, but it also can have other information. And then, I don't show this here because it's not technically part of the dance, but then usually pretty much immediately the app sends something to the host saying, okay, here's this OAuth token. I want these things. But this is the authentication part of all that process. Yes. All right. Any questions about that? About kind of the general idea? And it's okay, again, might not make sense yet. But we'll, we'll see how to actually apply that in a minute. Nope, and it is two. I'm going to try to finish if everyone, or if anyone can stick around, because I don't have that much more here, and we'll probably have to do a little bit more touch up later anyway. But all right, so I did want to talk a little bit about like the steps. Why are there all these steps, and what kind of, how careful should you be with these different levels of things? So the client ID, this one we actually send it a fair amount. We're sending it as part of the thing that we send to the user to go in their browser to go make the request. We send a client ID. And that's basically the same as knowing the name of your package or knowing your name, something like that. It's not, that one's not a big deal at all. Don't worry about protecting that. I will have it as an environment variable in a minute, but that's just because it's easier to store that way. But it's not anything that you have to worry about protecting. The authorization code, the thing that the client that the host sends back with the user, that's a little bit secret. It's more of a light green here because it can only go to the places that you specify that it can go to. And sorry, I had bullets about this. So it's only sent to that place that you said it could be sent. It's extremely short-lived, and it really should have a third bullet that you need the client secret for it to do anything. So if they don't know your secret as your app's secret and the auth code, and they're not at your server, they can't do anything with it. We're going to talk a little bit about the client secret and why I think it should be more secret than Hadley says in the Hitter2 docs in just a sec, though. Next up is a refresh token. We didn't really go into that, but that OAuth token that they send back, in addition to the access token, often has a refresh token inside of it. And the idea is that it acts as like a long-lived authorization code. You can send that refresh token and the client secret to a certain URL because the user has already said, hey, it's okay for this endpoint to act as me. And so you don't have to ask the user again in order to refresh the token. Usually that gets revoked if you do the whole auth process from scratch with that user on your app. Not always, but usually. But it's just a longer lived way so that you don't have to keep asking the user, hey, is it okay if I keep acting as you? Now they can revoke it at any time, but it tends to be a longer lived thing. Usually, if you are like writing code that is automated and you're doing OAuth within that code, the refresh token is the thing you want to save because it's the thing you can use to refresh, to get a new token. By default, well, not by default, but when you tell Hitter2 to cache your OAuth, which we're going to see in a minute, it saves the refresh token as well as all the other information about the, that's contained in the OAuth token. But yeah, this is the thing that you can just turn into an API, or sorry, not an API key, but a bearer token at pretty much any time. All right. And then the next level, client secret. It's kind of iffy of how dangerous is this. So within the Hitter2 documentation and some like conversations I've had with him in the Hitter2 repository, he points out that if someone wants to pretend to be you, they can set up their own client and just put your name on it. And it's not that big of a deal. And which is often true. And when doing that, they're pretending to be you. The user still needs to say okay, but they're saying okay to you. But where this client secret matters, where it's different than someone just setting up their own client that looks like you, is sometimes the client can do things that a hacker's client can't do. sometimes you install the client effectively, that you say, hey, Slack, this app, this app that is identified by this client is okay to use within my Slack. And if someone has your ID and secret, then they can be that client. And so they could do things as the user who didn't know that they were authorizing random other site to use it. They knew that they were authorizing you to use that integration. Sometimes also the client has API usage limits tied to it. So the YouTube API has limits both by user and by client. And so if you have other people using your client, you're going to run out of usage at some point. And so I do think this should be kept secret. It makes things hard for packages because a lot of times you want to include the ability to log in like within your package. There is some work done to obfuscate things within Hitter2, but this is still a somewhat unsolved problem. So that is what it is. In the YouTube bar package that Kevin and I have worked on, we don't include a client for this reason, that we don't want people using up our own or our API with their demos. And you'll see that, in the GitHub, some of the GitHub stuff, that it is using a generic client in that case, it's a full generic key, and then you have to authenticate to get past that. So actually that's a bad example, but the Google Drive stuff that they do, you can authenticate, and almost always you'll just authenticate with the Tidyverse client, but occasionally the Tidyverse client will have some blockage on it because too many people are doing stuff at the same time. So if you use your own client, you don't have to worry about that. So that's something to know when you're setting things up. The access token, the OAuth token, the whatever we're calling it, or the piece of the OAuth token that is the actual access, that's the thing we're protecting. So it can do whatever it's authorized to do. Usually it's easy to revoke. So I'm still just calling it orange because there's always the comparison of username and password. No, we don't want to know people's usernames and passwords because those are the things that you can use to reset everything above here. But it's better. It's short-lived. This access token, or supposed to be short-lived. I have to always say it's supposed to be, because if you go through the OAuth dance with Slack, they issue a token that lasts until you revoke it. And so just because it's a bearer token doesn't mean that it follows all the rules of a bearer token. It does have certain scopes associated with it, at least. Yes. All right, so real quick, we're gonna go through, I'll go through this just so you've seen it, but I'm not gonna, it's not perfect yet, and we'll probably end up doing it again, but I'll go through a kind of quick version. Hitter2 has OAuth client function. This is how you set up your client. So this is set up your app to talk to your client, which is your app. It's the identifier of your app. You give it that ID, the client ID that the host has given you, the URL where you send things to exchange for a token, and technically, optionally, the secret key, auth, params, and name, but the secret is almost always needed, and the key should never be needed. Where to send the auth, it defaults to body, and he says, usually it's body, and I would say at least 50% of the time it's header. So you'll have to watch for that. It should tell you, this is one of those where if you look at the API definition, it'll tell you, and it won't necessarily tell you clearly in the documentation. Auth params, I don't know of a case. I can't think of a case of these. I'm going to try to get those for the next version, where this would be random other things that this particular OAuth implementation tells you have to send with the code in order to get a token, or a full OAuth token, access token. So this can be any randomly named things, like maybe you have to also give it to the name of your app in addition to the ID and secret, or maybe you have to tell it some other piece of information. So that's what that's for. And then this name is just, you can give it a unique name. It defines where things are cached for hitter 2. And most of the time you can do this. If you are using a client twice, you might want to give it a name, like this is the one that I'm using for dev, and this is the one that I'm using for production or something like that. But most of the time you can just leave that blank. So really ID, token URL, secret, and probably auth are what you need to fill in there. Concrete example of that. This is a YouTube OAuth client. And so again, I have these set up as environment variables right now. I'm moving them over to keyring. And it's just grab that ID and the secret, and then the token URL is a hard coded set thing. Something I don't have an answer for yet is why in hitter 2 we don't also give it that auth URL, the first URL that we send people to within the OAuth client. I think technically those can vary, like you could use the same client at different auth URLs, but I don't know. I think it's kind of strange that he doesn't have you just bake that into the OAuth client, because that is part of the definition of the client usually. And so that takes us to this next slide that's very ugly and poorly formatted, but just to talk about it. The other piece that we need is this rec OAuth auth code. This is the one that will most often be using. That's kind of the dance that we've talked about. You send in a request, you send that client that we just created, you tell it what auth URL you're going to, and then everything else is optional. Sorry. You might give it scopes, which should just be a string or vector of scopes that are authorized. PKCE is proof key for code exchange. Basically, you set this to true unless it doesn't work, and then you set it to false. Or if the documentation happens to tell you that they don't support PKCE, but I don't remember ever actually seeing that in documentation. It's just something that newer OAuth hosts will have implemented, and it's a thing where it does a little bit of cryptography to make sure that the request is coming, like hasn't been intercepted in the middle. So use that if you can. I will say this is one of the first things that I check if something's not working with authorization. Often it's because PKCE doesn't work. So you set that to false, and then it'll work a lot of times. Auth params and token params, again, that is something that some might tell you are required. I can't think of specific examples. I haven't found any yet. Redirect URI, this is where the host is going to send the auth code back to. And if you're using this in local code, there's this OAuth redirect URI function that just is localhost. It'll send it to, localhost means me, like send it to my IP address. But sometimes you'll have to set this more specifically. A lot of OAuth hosts won't let you set just like localhost or 127.0.0.1, which is the IP address of localhost. They won't let you set that on its own. And so you have to give it more information. And the reason that this is going into this function, well, beyond sending that information over with the request, is hitter 2 creates a server at that IP address, listens for the response to come, and then sends that into RStudio or wherever you're using this code. So that's going on there. Cache disk, it can be really nice. If you're going to be working with this locally on your own machine, that just will save that refresh token automatically to a location in the hitter 2 cache. They do a thing that, I guess I get it, but they automatically clean out the cache. I can't remember what the cadence is on it, but it's different than, like, my refresh token might still be good. And if it's cached, it's going to clear it out. So I actually tend to collect the refresh token and then save that myself somewhere so that so it'll clear out when I want to clear it out. But their cache is, nice for more automatic types of things. And then finally, you can give it a cache key if you want this particular authentication to be stored, to be cached in a different place than some other authentication using the same client. All right, and just for a concrete example of that, I'm using YouTube in this. I won't be using YouTube in the final version of the book because it's much harder to set up than a lot of APIs, but just this is one that I had. So we can set up a request like normal. This is just a normal request, and then add on this auth. We gave it that YouTube client that we created. We tell it the URL where you do the authentication. The scope for YouTube is this just URL that is YouTube. I want all of YouTube, basically, is what I'm saying there. And then this is one where you have to give it a specific port when you set it up. So this is what I have set up as my redirect URI that's allowed. And then I can perform, and that will cache and it'll do its thing. It is quarter after. So that is what I have for today. I do have some other bits that I want to get into, but that should give you enough that theoretically you should be able to use almost any API at this point. And I'm out next week. I'm going to be traveling on Wednesday, so no meeting next week. So over the next 2 weeks, if you can play, that would be awesome, and let me know what doesn't work and what you couldn't, what you didn't know, and we can reincorporate that into earlier chapters.